For the second day of the course on circular manufacturing process and engineering. So today we have a series of lectures, beginning with the first lecture by Professor Taka, Design for Life Cycle. Yeah, Professor Taka.
Yes. So good morning, everybody. The title of my talk this morning is Design for Life Cycle. But before that, I want to touch on a bit about the design of life cycle, which is the life cycle planning I talked yesterday. So this chart you saw yesterday already. Why this is important is that you need a life cycle planning or the design of life cycle before product design and process design. And you also learned about life cycle options, which is the means to reduce the environmental load or the resource consumption in manufacturing. And now, so I would like to say a bit about the selection of life cycle option, the method of the selection of life cycle option, which we call disposal cause analysis. This analysis method is selecting the proper life cycle options. And disposal causes means why the product is disposed by the user. Because of the function, consumption, appearance is not so attractive anymore, or the capacity or size is not satisfied with the user's needs, or failure, or deterioration. This so-called disposal cause analysis is based on the QFD, quality function deployment. Do you know something about the QFD already? It's the first time to see this, to hear this name. So this is quite a famous method for the quality management in the field of the quality management. But I'll explain a bit about that. So the quality function deployment, QFD, is a method to transform the voice of customers into engineering characteristics of a product. So the designer have to specify the engineering characteristics. Yeah, how much the weight of the product, or how much is the size, what is the mechanisms of satisfying providing the function of the product and so on. But what the user need is the product should be usable, a good appearance, long life, and such things. So there is a different aspect. So you selected from the user's ankit or the information from the marketing department and so on. You should correct the voice of customers. And here these are the engineering characteristics. And what you should do is that this is the lifespan, and this user's voice is related to the, for example, gear hardness. So the double circle means there is a strong relationship between this VOC and this engineering characteristics. So, of course, lifespan is related to different engineering characteristics. That means this is a matrix between the multiple items and multiple items. So this is a QFT matrix. And here you should put the weight, which customer voice is most important. Then you put the high weight, and less important, then a smaller value, smaller weight. And what we want to do is transform this weight of the voice of customers to the engineering characteristics. So to satisfy the customer's need, which engineering characteristic is important for the designer? This can be analyzed by this matrix. So this is the so-called QFD matrix. And the way to transfer or transform the weight of the customers to the engineering characteristics, there are two ways. One is the so-called independent calculation. This means that, Here, the double circle has a 5 point, single circle has 3 point, and triangle is 1 point, for example. So this is the case of the example of the lighter, cigarette lighter. So nowadays, very few people use this because of the provision of the smoking in many areas. But anyhow, so for example, no ignition failure. This is one of the voice of customer. And then this voice of customer is related to the durability with the point of 3. And this voice of customer, the weight of the importance of the voice of customer is quite high, the 5 point. And then this 3 multiplied 5 makes 15 is the value. Then the same calculation is made for this double circle and this double circle and this triangle, and that makes 15, 20, 15, and 3. Altogether, the sum is 53, sorry. So this way, you can transform the weight of the customers to the weight of the engineering characteristics. But if you can see there are so many circles or the double circles or triangles in, for example, good design, although feel an attachment, although the weight is not so high, but this number, this weight of the contribution of this weight makes larger if there are many relations. Although this number is small, so sometimes this is not so fair. So in this case, you can use another way, prorate calculation. This is the way to distribute 5 points to each marks. So in this case, a single circle and double circle and single circle makes the sum of 11, and this weight is divided by 11 multiplied by 3 makes 1.4. So this is a way to distribute the value of 5 into 1.4, 2.2, and 1.4. So this is a so-called prorate calculation. Anyhow, so what we use the method of this QFD method is to we apply this method to the disposal cost analysis. And in the case of the disposal cost analysis, you put here the disposal causes. That could be function, consumption, appearance, capacity and size, failure, value deterioration. And again, you can put the importance on these causes. And this weight is transformed to the weight of the functions, transferring, this is the case of the ballpoint pen. And just for the explanation, this is quite a simple product, but then you have. So transfer ink, store ink, grasp, carry. So these are just an example of the functions of the ballpoint pen. And as I told you, as I explained you, the weight of the disposal cost is transferred to the weight of the function. And again, the weight of the function is transformed to the component of the ballpoint pen: top holder, body, bottom holder, ink cartridge, tip, and cap. So in this way, you can obtain the weight of the component. Which component is the most important in terms of the disposal cost? So this is the result. I don't skip the precise calculation, but anyhow, this is the result. The top is the ink cartridge, and for example, component with a large value of importance for disposal, in this case, in the case of the functional life, so upgrade is a proper life cycle option. Or in the case of the physical life, maintenance could be an option. And also the component with a small value of importance component can be reused. So in this way, this is just one of the methods to choose the appropriate life cycle options. But this can be a kind of the powerful method for selecting the life cycle options. Okay. So, and also there is a procedures of the there is a procedures of the life cycle planning. So this is proposed by the Professor Kobayashi of Osaka University when he was in the Toshiba company. He first worked in the Toshiba company about the life cycle management, and then came into the Osaka University. So he proposed this kind of the procedure of how to plan the life cycles. So it consists of the product, the selection of the concept of the product, and the selection of the concept of the parts or component. And he uses the QFD analysis. So I don't have enough time to explain the detail of the process, but just go through this method for catching the rough idea. So this is also the QFD matrix, customer view and designer's view. And he proposed to select a target specification. And in terms of the environmental requirement, environmental characteristic, company policy, marketing impact, environment impact, and you know that EPN means environmental priority number. So which is the product of the company policy, market impact, and environmental impact. So which is evaluated by the 5-point scale for each. And this is the life cycle phases: procurement, production, distribution, use, end of life. And for each life cycle phase, input material, input energy, toxic substance, waste, atmospheric emission, hydrospheric emission. So these items are evaluated in terms of the environmental requirement, environmental characteristics, and so on. So this is the way of analysis of what is required for the product. And sometimes environmental requirement is not consistent with the quality requirement. In this case, these are the quality requirement, and this is the importance transfer these quality characteristics, and in QFD you should choose the baseline product, and also compared with the competing product with other companies, and then you should set the target value. So you need to exceed the performance of other product from the other company. So, but in this case, quality characteristic A is consistent with the environment requirement, but this is not the case. That means a conflict between the quality and the environment. So in that case, so you have to compromise that target value, such as 5 should be reduced 3. And sorry, sorry for the Japanese character, but you have here the quality requirement, environmental requirement, and these are the solution ideas. This is in the case of the rice cooker machine, electric rice cooker. And the solution means that, for example, induction heater, IH heater, induction heater, the coil of the induction heater should be reused. So this is one of the solution idea. And this is the product concept. Reduce the energy consumption. This is one of the concepts. Then in this concept, you should take this solution, and if you take the reducing the resource consumption, you can take this solution and this solution and this solution. So that means that the combination of one combination of solution could be a one product concept. And each solution should be evaluated in terms of quality, environment, corporate cost, and user cost. And then the concept, I mean that these are the concepts, the combination of solution should be evaluated in this kind of the chart. And well, this is the baseline product, and energy saving long run is superior in terms of user cost and environment, and so on. So by evaluating in this way, you can decide which product concept should be taken in this case in this moment. Okay. So the procedure is a bit complicated, but I hope that you can get the certain flow of the processes. Okay, so far these are the example of the design of life cycle or the life cycle planning. So, do you have any question so far? There are so many books about the QFD. So, or just Google QFD. You can get the information about that. And this is quite general topics in the area of quality management. So, I recommend you to look at some explanation. Yes, please.
So, when we are standardizing the customer's review, what are the standard reviews we have to keep in mind? Because the customer has, when we go out in the market and we do a survey, and into that survey, 10, 15, 20 points. But what are those important points which we have to consider for this QFD?
Yeah.
And then there are, so many standards of the industry or the engineer which they have. So, but from those so many, how do we consider that these are the important factors which we have to consider?
Well, I don't know much about how you can, in practice, how you can choose the engineering characteristics. Maybe based on the experience of the designer. In the case, for the case of the engineering characteristics. And as for the customer's voice, you have to collect a lot of information as much as possible from the user's ankit or the survey of the market survey and so on. So then maybe again, I don't know exactly, but in practice, maybe you need to select items of the customer voice based on the experience. Or it's dependent on the, of course, product. So usually the QFD matrix become a very huge one. So how to categorize? The first thing is that you should categorize the voice of customers into some categories. Then in this way you can reduce the QFD matrix. And if you find a very important category, then you look into detail in this category. So this way you can proceed step by step. That is, I think, the common practice.
Maybe we can also set the product goal, that this is the goal which we have to achieve, and then further we can categorize both the categories.
What do you mean by goal?
That I want to make a product.
Yeah, so that is the intention of the company or the designer, and that can be reflected in the design concept. So which design concept you should select? That should be decided by the company policy or the designer's policy. Okay? Okay, so then the next topic is design for life cycle. Meaning that how you can design the product for the life cycle for the purpose of the reducing the environmental load reducing the resource consumption and so on. And it is well-known chart. This is a well-known chart that means the majority of life cycle costs are determined in the early stage of product development. So this is the case of the cost, but the same concept can be applied to design for environment. So the impact of the environment or the amount of the resource consumption should be considered as much as early in the stage of the design is quite important. And this chart, the data is a bit old one, but this chart shows the contribution of recycling cost reduction measures. So inner circle shows the percentage of the recycling cost. So disassembly 26%, end of life treatments 36%, correction 38%, and so on. And the outer pie chart shows the potential contribution of recycling cost reduction measures. So design improvement has the biggest value. The message is the same as the last slide. So you need to consider the life cycle in the early stage of the product development. So, but the concept of the DFX or the DFA, which was developed in already 1970s and 1980s, DFA method has been developed quite strongly, and that is the design evaluation method in the early stage of the design, as I told you. And the method should be subjective and quantitative evaluation and usable without specific knowledge and experience, because designer does not know everything. So, for example, designer is not a specialist in the production field, but assembling or the manufacturing should be, design should be easy to assemble, easy to manufacture. So how you can reflect this kind of concept into design? So you need some kind of the method or to support the designer, method to support a designer to make easy assembly and so on. And first, it is said that the design for assembly, the method was developed. And then the concept of the DFA has expanded to DFX. X is manufacturing, test, reliability, maintenance, disassembly, and the environment, and so on. And this is just one example of application of DFA. This is initial design. So many parts, so many processes are needed to for the assembly. But this is the improved design based on DFA. So, but the method behind is that there are regularity of assembly and disassembly motion. In the case of the assembly motion, the number one grasp, regrasp, transfer, adjust orientation, joint, changing posture of the product, and so on. And this is the regularity of disassembly motions. So if you look at the actual assembly motion, you can divide into these 7 motions. So I'm sorry again, this is in Japanese, but sorry. These are the basic motions of the consisting of the assembly or disassembly, and these are the factors, variable factors by design. How much is the dimensions? What kind of the fixing method are used, a screw or the snap fit, and so on. And these factors are aggregated into the requirement, and then after that, so they are categorized into 4 approaches: part design, joint design, process design, frame design. And these systems are developed by Professor Yamagiwa. He worked in the former time. He worked in the Sony, and he developed Walkman machine. You don't know, you may not know. So that was the first tape recorder, mobile type tape recorder, very small size, and then you can hear in a walk during the walk. So that's why it is called Walkman. Anyhow, so he proposed that 4 design approaches. But 20 minutes or more around.
35 minutes.
Okay. So the frame design means aggregation, unification of direction and layout, early removal of variable parts. So, and process design, serialization of identical operation. If you unscrew or the screw, then you need to the same operation altogether. So not to screw and other tool, then again the screwdriver and so on. So that is not efficient ways. Sorry. And also the part design, easy to separate, easy to identify the direction of extraction and so on. And joint design, easy to separate. I mean that screwed or the snap fit or the any other joint method. So these are the 4 design approaches in the assembly and disassembly operations. And design for environment. The term design for environment was originated from the program of EPA, OPPT, in already 1992. So it aimed to reduce environmental impact as much as possible in the product design and planning stage. And this concept is adopted to the ISO technical report 14062 environmental management. But this was published in 2002, but already withdrawn, and the concept is integrated in the environmental management system. Guidelines for incorporating eco-design was published in 2020. So anyhow, so the concept is that when the product become the end of life, then consider how you can treat. That is too late. So you need this aspect, consider this aspect at the design phase. That is the message of the design for environment. And later on, the term design for environment is nowadays many of the people are called eco-design. So this is these are the same concept that the name is changed to DFE to eco-design recently. And this is a kind of the eco-design guidelines. And this is the life cycle options: reduce, maintenance, reuse, recycling, disposal. And this is the structure aspect. And this is material aspect. What type of the material should be chosen. But there could be an inconsistency between policies or the approaches. For example, so the modular design is quite a effective design method for the eco-design. For example, if you want to recycle, easy to recycle, then you need to make a module with the same kind of the material. Then you can extract the same material very easily. But if you want to adopt reuse options, then module should be the component with the same lifespan. So then, if you have a module with a short lifespan, then you should exchange it. You can exchange it with a new one to expand the life cycle or the life of the product. So the term modular design is the same, but what is the purpose is different. If the purpose is different, so the way of the module, the making the module is different. So this is an important point of that eco-design. there are many aspects of the eco design. For example, this is for the plastic. This is for the plastic recycling. So you should indicate the precise material, what type of the material is it, and what kind of additives you have in this material, and so on. And this is the case of the use of the compatible rubber. Compatible rubber means you don't need to peel the rubber for the recycling, because the peel is also the same material as the parts. Okay, and this is an example of easy to disassembly fasteners. So snap fit is quite easy to assemble, but if you design like this one, so it is not easy to disassemble. But if you change the shape, you can disassemble just putting it. But sometimes, so during the operation, it failed to remove it. So in that case, you can use this kind of the assembly design, or like this one. Of course, you need to consider the appearance. Some designer is put the importance of the appearance, and they don't like this kind of thing. So you have to compromise this kind of the aspect. And this is also the using the shape memory alloy. Do you know shape memory alloy? So if you for example, so this is the rivet, and you open the tail to fix. But if you put the heat, raise the temperature, then the part becomes the original shape, returns the original shape, and easy to disassemble. And this is also the same use the same material for the washer. Washer opens if the heat applied, and easy to disassemble again. And this is the example of the fastener, the number of fasteners. So in this case, you need 3 fasteners or screws. But if you change the shape like this one, you need only 1. Or this is the case of the unifying the direction of the screws. So this is also the example of the easy to disassemble design. And this is also the a bit old example, but the case of the Philips LCD TV. The structure is made of the aluminum, easy to recycling, and electronic component is minimized, and with assembled with access, easy to access, and that makes the disassembly easy. Okay. The summary: planning and managing a whole life cycle in a consistent way is essential for the successful implementation of circular manufacturing. So in this lecture, you have learned an outline of life cycle planning method, as well as some examples of the method for selecting life cycle options, depending on the life cycle strategy and product and component characteristics. You have also learned the concept and some example of eco-design. Life cycle planning, including eco-design, is a complex task in which there are many factors to be considered. Therefore, effectiveness of the planned life cycle scenario and the selected life cycle option should be carefully evaluated. For this purpose, life cycle assessment and life cycle simulation are effective tools, which I'll present in this afternoon. Okay, thank you very much for your attention. So, any question, Noah?
Difference between environmental factors considering the line manufacturing and the circular manufacturing. Present, is there any environment concept which is right now using in circular manufacturing?
I'm sorry.
Apart from line manufacturing,
Pardon?
what are the current environmental factors are using in circular manufacturing? Is there any environmental factors which are using in circular manufacturing?
In the material?
In circular manufacturing process, sir.
Yeah,
In circular manufacturing
Yes.
process, what are the environment concepts are using currently?
Environment concept.
Yes.
What do you mean by environment concept?
You are saying that environmental factors in the slides, sir. The system 14062, you are saying environmental conditions.
But what I want to say is that what kind of the strategy
Yes.
to reduce the environmental impacts?
In circular.
Yeah, it depends on the product characteristics, the type of the product, and also the type of the market or the type of the usage. So that's why it depends on and how can I say, there are so many ways and you need to select. So there's no one solution. So why you need a method to select the life cycle options or the life cycle design.
You mean to say that, sir, this pen is made from line manufacturing. This is a pen which is for disposable environment. This is based on some environmental factors. This is based on some recycling environmental factors. What the factors we have to consider to do this circular manufacturing?
Yeah, so that's why. So I said that you need a assessment method. So which is better? That should be assessed. And then one way is the life cycle assessment, and another way, what I want to explain later, is the life cycle simulation, and that is very important point. So sometimes we introduce the recycling option, then I'm doing the better way, but sometimes it is, if you evaluate the result, then sometimes it's not so effective way. So it is a bit complicated problem. In the eco design is a complicated issue, so you need to evaluate in an appropriate way. So, is this the answer?
Yes, understood.
Thank you very much for your question.
Any more questions? Okay, if not, then once again I'd like to thank Professor Takada for the nice presentation.
Thank you very much.
So we'll have a break.